Hello everyone, welcome to this video where we're going to be looking at how we can use S-TIMBER to model area loads and also specify the span directions for which those area loads are going to be decomposed down to member loads. So in this example that I'm using, I have a timber frame that's been constructed already, and I'm going to look at a couple different ways that we can model this. This all revolves around the usage of panels, so I'm going to use this floor panel option, and you'll notice we have the option to specify the panel type. I can specify the panel type as either a surface, area load only option. By default, it'll be set to mesh, which is going to generate a finite element mesh. But in this case here, I'm going to go with a surface area load only option. And here I can specify the type of span I'm going to be using. I'm going to say that it's going to span as a two-way span. And I'm just going to basically trace out this model, or this panel rather, over top of my model, by just clicking on the vertex of each one of these corner points here, or external points. And just close it on the last point there. And I should also note that by default, each one of my members is being told that it will support area load. Now we can configure this at any point by just left clicking on a member, and we have this option that says accepts area load, and we can toggle that on or off depending on our own requirements. But I'm going to leave them all as accepting area loads for now, and I'm going to switch from this object view to the physical element view. And here under the physical element view, I can see that each polygon or sub-polygon within that panel has been broken down, and it's assuming again that every single member in my model is supporting area loads. So it's looking at basically the tributary areas of each one of those members and calculating those for us. So I can see how those are broken down for us here. In this scenario, I have one single panel that is over top of my entire floor system. However, if I wanted different span directions for different sub-polygons, I could break my panels down into smaller components. To do that, for example, I can just left-click and delete this panel, and let me just draw another one using the same parameters. So I'll draw one that goes in this sub-polygon, another one that goes over here, and finally one more on this side. Now I can see that, again, it's by default going to use the span direction that I specified in the tool window. So if I go to the physical element view, I can see that it looks the same here. It's set up as two-way span. However, this allows me then to go in and I can select the panel handle at the center of the panel there. And for each individual panel, I can go in and I can revise how that's set up. It can be a long one-way span, so spanning in the long direction. It can be a short one-way span, spanning in the short direction. And I can do this for each individual panel if I wanted to control it that way. So we can have different span directions depending on our own requirements. Maybe just for variety, I'll make this one a long direction one-way span. And once I'm done doing that, I can then go ahead and apply some loads. So let's just assume here we're going to have a single load of 5 kPa applied to each one of these panels in the global Z direction. And we'll see that it is being applied as per these different span directions. But what's going to happen is, if I go to the finite element view, I can actually see those loads here and how they're basically being decomposed to those area load members. And what's interesting here is I can use this load selection tool, and I can select the magnitude. So I can see here, for example, this particular panel again had 5 kPa load, and it was spanning in the long direction. And you can see the member load on this side is 17.5 kilonewton meters per meter rather. If I look at another example, I'll look at this triangular shaped load, and I can see here that it's specified in 3 different entries. It starts at a magnitude of 0, then it ramps up to a magnitude of 7.5 kPa, or kilonewtons per meter rather, at half the member length, 0.5, and then back down to 0. So we have a way of viewing this information after those loads have been specified as well. Now if you'd like more information on span directions, perhaps you're also an S-frame user, we have plenty of videos available on that as well. Feel free to reach out if you do have any questions, and we hope to see you in future videos.